Hello again. In the last video, I showed things like voltage drop and resistance, and I also showed amperage of a series circuit. But I also showed you guys the three types of resistance that equal up to the total impedance. But in this video, I'm just going to show you how to calculate voltage, amperage, and ohms or resistance in a parallel circuit. So this is unique to a parallel circuit, and so the difference between a parallel circuit and a series circuit is the way you calculate their resistances, but also there's not a voltage drop across a parallel circuit. Parallel circuits do not experience a voltage drop. So to calculate the resistance inside a parallel circuit, what you do is to find the total resistance. You have to do some algebra, and it can be a little tricky. I won't bandy words here, but it is kind of tough for some people. And you take 1 divided by 1 over the first resistance, and you add that to 1 divided by the second resistance. And you go on and on and on, however many resistances you have inside your parallel circuit. Now this algebra can be tricky, but there are ways to make it easier. And I'm going to just show a quick example of how I would tackle a problem like this to make it easier and not so hard on yourself. So I'm going to just draw the circuit real quick just to show you what's going on here. So this is the parallel circuit, and it's got lines coming down like that. Here's a load, like that. You got another line, got a load, coming down like that. Got another line, and a load coming down like that. So there's 3 loads in this parallel circuit, and I'm going to say this is 10 ohms. I'm going to make this a real easy one. This is also 10 ohms, and this is 10 ohms as well. So just to make the math a little simpler, I don't have a calculator on hand. And so this would be 3 loads inside a parallel circuit with a, we'll say it has a 120 volt power supply. Okay, and here's our switch right up here. Okay. So what I'm going to do is I'm going to show you a way of calculating that total resistance. Because you can't just simply go 10 plus 10 plus 10, oh, 30 ohms. No, that would be true in a circuit series, but in a parallel series we have to use that equation that I showed you earlier. So let's erase this real fast. Okay, so we have 3 resistances all equaling up to 3 resistances each 10 ohms. So if you take 1 divided by 1 over 10 plus 1 over 10 plus 1 over 10. Well, this is nice because we have a common denominator in each of these fractions. Now what I would do is just handle the bottom first. Yeah, it looks confusing because it's 1 over everything, but just handle the bottom first. Do the denominator, which is the bottom of your fraction, first, then worry about your numerator, top of the fraction, later. So just handle each individual. Now this is a sum of fractions. So the way we do that is, since we have a common denominator in each of these fractions, 10, 10, 10, you just leave it alone and only add the numerator, 1 plus 1 plus 1. So that's going to be 1 over 3. 1 plus 1 plus 1 is 3. 3 over 10. Okay. Now that simplifies the bottom, but you still have this numerator to deal with, this 1 up here. Okay, so the way I see it is, if you remember from back, if you learned fractions and division and multiplication, things like that, you can't divide a fraction, 2 fractions like this. So in other words, if I took 1 divided by 3 over 10, because that's what this is, 1 divided by 3 over 10. This is not proper math. You have to do a reciprocal, right? So that would be 1 times 10 over 3, because you can't divide fractions like that. It doesn't work. So 1, now we can do this. This is doable. So 1 times 10 over 3. Okay? that's going to be like 3.33 amps or something like that. Yeah, that looks about right. So, repeating board. So that's how many or wait, what did I just do? I didn't do amps, that's resistances. No, that's 3.33 ohms. Jumping ahead here. So, there's 3.33 ohms in the total parallel circuit. And that's how you solve for that. So we know that there's that many ohms going throughout the entire parallel circuit, and after that it's easy. The way you solve for voltage and intensity is very simple in a parallel circuit. As I said, there's no voltage drop inside of a parallel circuit, so the E of the total should be equal to the voltage of 1, which is equal to the voltage of 2, which is equal to the voltage of any number after that. In other words, the voltage is the same. You don't receive a voltage drop, so whatever voltage is coming out of that power supply is the voltage that you're going to have in your parallel circuit. Okay? Amperage is also very similar. Amperage is constant throughout the entire. Let me look in the book because I don't want to tell you guys something wrong that I could be mistaken here, but yeah, that looks about right. I believe the current draw of a parallel circuit is constant throughout the entire circuit. So intensity total should be equal to intensity 1 equals to intensity 2. In other words, the current draw is the same throughout the entire parallel circuit.